Imagine standing on a beach, watching the waves gently rolling in. A few hours later, the water has completely retreated, exposing a vast stretch of wet sand. And then, as if by magic, the water slowly creeps back in. This happens every single day, everywhere in the world. But have you ever stopped to wonder, why? Most people think tides are just about the moon pulling on the ocean. And while that's partly true, the full story is much stranger, more complex, and even mind-bending. In fact, the way tides really work baffles even scientists at times. They don't just follow a simple pattern. They behave like massive planet-wide waves, obeying hidden rules that go beyond just the moon. Stay with me, because by the end of this video, you'll understand the secret physics of tides, why they don't always rise and fall at the same time, and why some places experience barely any tides at all, while others see walls of water rising over 15 meters high. This is how tides really work. Let's start with what most people already know. The moon has gravity, and just like it pulls on the Earth, it also pulls on the oceans. This creates a bulge, essentially a massive bump of water, on the side of Earth facing the moon. So, when that bulge passes by your location, the water level rises. Simple, right? Except, there's a problem. If this were the full explanation, we'd only have one high tide per day. But in reality, most places on Earth experience two high tides and two low tides every single day. Why? The answer is a second, equally mysterious bulge, one that happens on the opposite side of the Earth from the moon. This second bulge is actually not caused by the moon's gravity pulling water away from Earth, but by something completely different: centrifugal force. Yes, you heard that right. Tides are not just about the moon's gravity, they're also about the fact that the Earth and the moon are actually spinning around a common center of mass, like an invisible seesaw point. This motion creates a force that flings water outward on the opposite side of the planet, forming that second bulge. So at any given time, there are two high tides on opposite sides of the planet, and two low tides in between them. That's why we get two tide cycles per day. Another factor influencing tides is the tilt of the Earth. Since our planet is tilted on its axis by about 23.5 degrees, tides are not uniform around the world. Some locations experience stronger tides due to their position relative to the moon and sun, while others see smaller fluctuations. And here's something even stranger. Tides aren't actually waves moving across the ocean. Instead, they're more like the entire ocean shifting in a slow-motion rocking pattern, controlled by gravity and the rotation of the planet. Tides also play a role in shaping coastlines. Over millions of years, tidal forces have carved out bays, estuaries, and even influenced the formation of islands. The repeated ebb and flow of tides gradually erode land masses, changing the geography of the planet itself. Many explanations oversimplify tides, suggesting that water is simply pulled into bulges. But in reality, tides are more like a global hydraulic pump. The key force at play isn't just the moon's gravity, it's how that gravity varies across different points on Earth. Imagine Earth as covered entirely by an ocean. Now turn off gravity for a moment. The entire planet, including the oceans, would accelerate toward the moon. However, the side closest to the moon is pulled slightly harder, while the side farthest away is pulled slightly less. This creates a stretching effect, which results in two bulges on opposite sides of the Earth. But here's the real twist. The water itself isn't being lifted. Instead, tidal forces act sideways, pushing water toward the Earth-Moon line. These tiny, continuous sideways forces build up pressure, squeezing the ocean like a planet-sized blister. This is why tides happen everywhere, even though the force of the moon's gravity is incredibly weak compared to Earth's own gravity. This same force is what creates tidal currents, massive movements of water that affect navigation, fishing, and even marine ecosystems. Some of the strongest tidal currents in the world can reach speeds of up to 16 knots, about 30 km/h, creating real rivers within the ocean. Additionally, tides have an impact on marine wildlife. Many species, including crabs, sea turtles, and certain fish, rely on the tides for breeding and migration. The timing of high and low tides determines when some species lay their eggs, while others use tidal currents to travel long distances without expending too much energy. Tides also affect groundwater levels. In coastal areas, tidal fluctuations can push seawater into underground aquifers, influencing the availability of fresh water. This effect is critical in places that rely on wells and natural springs for drinking water. We've all heard of places where tides reach an astonishing 16 meters in height, like the Bay of Fundy in Canada. But why do some regions experience extreme tides, while others barely notice a change? This is due to something called oceanic resonance. Some bays and estuaries have the exact shape and depth to amplify tidal waves, much like how a swing moves higher when pushed at the right moment. The Bay of Fundy, for example, has a natural oscillation time that matches the tidal cycle, resulting in enormous walls of water moving in and out daily. Another interesting effect of tides is tidal bores, which occur in narrow rivers connected to the ocean. A tidal bore is a powerful surge of incoming water that travels upstream against the river's natural flow, forming waves that can be surfed for miles. The Amazon River has one of the longest tidal bore waves in the world, known as the Pororoca. The influence of tides goes far beyond the natural environment. They have been crucial for maritime navigation, helped armies win battles, and even influenced the construction of ports and coastal cities. During D-Day in World War II, the Allies used precise tidal calculations to choose the ideal moment for landing in Normandy. If they had miscalculated, soldiers could have been trapped in Nazi obstacles or stranded before reaching the shore. Even today, tides are becoming an important source of renewable energy. Tidal power plants use underwater turbines to generate electricity from the constant movement of tides, providing a sustainable energy source that could be vital for the future. Tides also play a role in climate regulation. By driving ocean circulation, they help distribute heat across the planet, influencing weather patterns and even long-term climate changes. Tides are one of the most powerful and fascinating phenomena in nature. They not only shape our oceans, but also influence our climate, cities, and even the future of space exploration. So next time you see the tide rising or falling, remember, you are witnessing an invisible force that has been shaping our planet for billions of years. Hope you liked it. Don't forget to subscribe.